Note 6.2 example 11 is another possible situation where we could solve a right triangle finding all missing sides and angles. So we are given the length of one leg and the length of hypotenuse, and we need to find the second leg. So I'm going to label that side length x, and now we can use the Pythagorean theorem. So we can say that x squared plus 13 squared is equal to 22 squared. So x squared plus 169 is equal to 484. Subtracting 169 from both sides of the equation, we get x squared is equal to 484 minus 169. So x squared is equal to the square root of 315. Take the square root of both sides. So x is equal to the square root of 315. If you factor this, you'll see that this is actually 5 times 63. So, and 63 is 9 times 7. So 9 is a perfect square factor. So x is equal to 3 rad 35. So this is the third side length, 3 rad 35. And now we need to find the measures of the angles T and I. So initially, I'm going to focus on angle T. Let's say you could do either one. And I'm going to label the side length. So the side opposite the right angle is the hypotenuse. So that's the hypotenuse. The side opposite angle T is going to be labeled opposite. So opposite. And the third side is the adjacent. So you can use whichever trig ratio you'd like. I am going to focus on the integer number. So I'm going to focus on the adjacent and the hypotenuse. So if I think about SOHCAHTOA, and I want the ratio that has adjacent and hypotenuse in it, I will use cosine. So cosine of angle T is the length of the adjacent side, which is 13, over the length of the hypotenuse is 22. In order to determine what the measure of angle T is, we can take the inverse cosine of both sides of the equation. So we have T is equal to cosine inverse of 13/22. And if you push that, enter that in your calculator, you'll find that the measure of angle T is 53.8 degrees. Make sure your calculator is in degree mode if you want the answer in degrees. So the measure of angle T, I'm going to write that in, is 53.8 degrees. To find the measure of angle I, you could use a trig ratio. So you could use, you'd probably use sine. So you'd probably do sine of angle I is equal to 13/22. And then to determine what I is, take the inverse sine. So I is equal to sine inverse of 13/22. And that turns out to be 36.2 degrees. But it's actually easier to not use a trig ratio here. You can simply use the triangle sum theorem. So we know that the measure of angle I is going to be complementary to the measure of angle T. Or you could say the sum of the measures of the angles in the triangle is 180. So we could say the measure of angle I is simply going to be 90 degrees minus 53.8 degrees, which is equal to 36.2 degrees.